Okay, so you're now probably ready to use R in Anchor, but just a few things first. And just some general kind of tips for the class. As I said, it's a good idea to read around the subject. I can't teach you everything. I can't teach you every R command. The more you do, the better you'll be. Don't give up at the first attempt. This quite often happens. You know, you can be looking at code for a while and you think, "Oh, I just copied it. I did it exactly the same as he did. It doesn't work. Something's wrong." Sometimes just going away, taking a break, coming back, thinking through it logically can actually help you. One good idea is just to go through your code line by line. See if one line works, move on to the next line. One thing with R is it's case sensitive. About 50% of the student errors I deal with is people writing in uppercase instead of lowercase or vice versa. Your classmates are a resource. I do allow you to work together on homework, so you've got to write the actual writing part. We explain the results you need to do yourself. You can't copy there, but you're certainly allowed to help one another and work with one another. And that's really because people have a range of backgrounds and experience. You know, I can guarantee that you will get frustrated in this class. You might swear at my name once or twice in the class. But if you have a good group of 3 or 4 people, usually one of you will be able to find what the issue is and what the error is. And again, it's not something that comes easy. Debugging code is something of a learned skill. Now, if all else fails, you're welcome to email me. But, you know, what I don't appreciate is like, this is terrible. It doesn't work. You're an idiot. Just, you know, give me a list of all the steps you did. If possible, include your code. Now, one thing I will say for homeworks is I probably won't tell you exactly what the issue is. I might give you a hint. Or, you know, if you email me, I might tell you the first one. Then you email me again and again, and I gradually get less helpful. You know, that's just, you can't really learn unless you do things yourself. And I've got to be fair on all the students for homework. Okay, so let's move on. And I'm just going to go through the code, but you can follow it. You can kind of follow it. There's some extra information available in the notes. So we're trying to work out this very, very simple commission for salespeople. And what we do is a salesperson brings in a certain amount of revenue from new customers. They also have existing customers who may or may not renew. So they actually get 2% or 0.02 of new revenue and 1% or 0.01 of renewal revenue. And this is pretty common in sales because if you just give salespeople commission on new revenue, then they tend to ignore existing customers. So most marketing organizations try and make their commission structure multifaceted these days. So imagine we have Pamela, and she had $740,000 of new revenue and 1.6 million of renewal revenue. So we've defined commission rate using our weird R equals sign to be 0.02. We've defined the renewal rate. Now let's just calculate, and this is just, we're just using R as a calculator at the moment. We've got Pamela's commission is her new revenue times the commission rate plus her existing revenue times the renewal rate. There we go. And if you look now in the environment, we've actually worked out Pamela's commission. So Pamela's commission on top of her base salary is $30,000 a year. So we can just type it. We can also get it by just typing it, and it will give me the $30,000. Now, let's look at this. What these values here, the 0.02, 0.01, 740,000, these are what's called scalars. They're single numbers. Let's actually get a bit more complicated. Let's put them in something called a vector. In R, you define a vector, which is just really a list of numbers, by using a C and brackets and then putting commas between your numbers. So we've got C 0.02, 0.01 has a vector with 0.02 and 0.01. So let's have a vector for the commission values, and vector for the revenue. And we can actually, just example, just show you what the revenue, it is a vector. And you can see up here in the environment, we have the Pamela revenue, num1 to 2, that's just showing it's a vector, and then the two values in the vector. Okay, so what we're going to do now? Well, from those values, we want to actually calculate the commission. And it's really easy. What we do is we multiply and this little star sign, this is taking you back to your pre-calculus, I guess, where you did like vectors and matrices. The star sign is like a scalar multiplication. And all that means is it multiplies each element of the commission vector by each element of the Pamela vector. So it will do 0.02 times 740,000 and 0.01 times 101,600,000. So let's just, before we do the sum, let's just see what that gets us. And that's, again, if you just look and multiply the two, you will get these values. So Pamela gets 14,800 on new commission and 1,600 on existing commission. Now, we want the final adding them together, and we just use R as a function called sum, where we can add them together. So let's define Pamela com2 as the commission calculated in this way. Now we can actually write it. And you can see 3,800. It looks like the same number we had before, but let's just check. What am I doing here? Double equals sign, and it comes back true. Now what this is I'm just asking the question, is Pamela com equal to Pamela com2? And this is what we call a comparison operator. Are these guys actually equal to one another? So the answer is yes, they're equal to each other, so that's going to be true. If I put Pamela com, is it equal to, say, 20,000, which is not, I'm going to get false. Okay, and let's try somebody else, and I'm going to do through this quickly. So we now have Miguel, got these values of sales. This is his new, and this is existing. We do exactly the same as what we did with Pamela, just multiply it by the commission percentage proportions, and we see what Miguel gets. So Miguel gets a little bit more, gets 35,400. And now we can say, compare these guys, and they're not equal to each other. And Pamela, another kind of comparison operator is this one, just says Pamela is less than Miguel. Yes, it's true. She had 30,800. He has 35,400. And Miguel is greater than Pamela. So again, we'll use these more advanced, but these are just saying, is one value equal to each other? Is one value more than each other? Is one value less than each other? Comparison operators. Now, let's get a bit more complicated, because that was too easy. So what we're going to do is we're going to have all these values, and we're going to put them in a matrix. Now what we're going to do is we're going to say we now have 3 salespeople. We've got Pamela, Miguel, and Robert. And each of them is going to have a row in the matrix. And they're also going to be values for new and renewal. So we should have 6 values. We have Pamela's values, Miguel's values, and Robert's values for both new and renewal. And what we do is we use we basically create our list with all of these values, and then we say we want we want 3 rows and we want 2 columns. Now let's just create this matrix, and this is all the matrix command does. It takes in a vector and then a specification of the matrix. an important thing by default is it goes via column than by rows. I think it has you can send it a by row command, but you see here 74,000 is the kind of the new value for Pamela, then the new value for Miguel, then the new value for Robert, and then the same for the renewal values. Now, this matrix doesn't tell us much at the moment, so we can actually add some labels to it. We can have basically the row names function allows us to set a vector of row names, and the col names function allows us to set a vector of column names. You can see there's 3 row names for the 3 rows and 2 column names for the 2 columns. And now let's look at sales revenue. Yeah, you can see it gives us a little bit more information. Now, we can do the calculations. Now, we're not necessarily going to do a lot of matrix algebra in this class. This isn't a math class. But what we're doing here is we're multiplying sales revenue by my multiplier proportion. And literally all we're doing is each of these rows we're multiplying by 0.02 and 0.01. So the Pamela row, we multiply by 0.02, 0.01. The Miguel row, we multiply by 0.02, 0.01. And exactly the same with the Robert row. Don't worry, if you don't understand matrices, don't worry too much about this. I don't want to teach like matrix algebra from scratch, but if you have, basically we've got 3 rows and 2 columns, and we multiply by this vector here. Just imagine it's sitting to the right of these guys, then each of these rows is multiplied by that vector. And there we go. We actually get, this does basically all the calculations we've done. It does in a single calculation. So we have Pamela, Miguel, and Robert. And you can see here that Pamela has 30,000, Miguel has 35,000, and Robert has 34,000. So to finish off this little section, I did give you some links here. We looked at these very fundamental concepts, data types. We defined scalars, vectors, and matrices, and operators. We defined basic arithmetic, plus, minus, multiply. We looked at these comparison operators. Then we looked at this kind of at the end, how to multiply a matrix by a vector. And there's some nice tutorials here on how to do things a little bit more advanced than what we're doing in this class. So again, as you go through this, it's always a good idea just to learn that little bit more. Okay, so that'll be the second part, and then the third part we'll begin to look at some more kind of complex analysis.